So our objective today is to understand work problems. Shh. And when we talk about work problems, it's two or more people getting a job done. And I shouldn't just say people, because we're going to talk about pipes too. Okay, so work problems dealing with two or more people or objects getting a job done. Now, for most of the types of problems that we talk about, the people are working together. There's some occasions when they're working against each other, and so that kind of changes. There's a little bit of an exception to what we're going to do. So basically what I'm going to do is give you some scenarios, and then what we're going to do is do some examples that go with those scenarios. Okay? So scenario one. Work together, start to finish. Now, what's very different from what I'm going to teach you is that we're going to come up with fractions that represent the amount of work each individual will do while working together. The big difference, what's going to get done is a complete job. Ms. Sprouse? Okay. So our fractions are going to lead to having one complete job. Okay? All right, if I look around and see somebody who's not taking notes, my mind's going to change about you guys taking one more test. So I would suggest that you all are writing down some stuff right now. So we have two scenarios. We usually have how much time a person is working on a job if they were by themselves. And then we also need to figure out how much time that they're going to spend together. Okay. Now, in some scenarios, I know the together time. In some scenarios, I just know their alone times. So there's three different pieces of information. One of them has to be missing. So work together, start to finish. Let's see. Together, over, alone. Together means how much time do they work together to get the job done. Alone means how much time could they have done the job if they had nobody else working with them. This is person one, or object one, plus together, over, alone. And this would be for person two, or object two. Usually it's a machine of some sort. Jason, it's you who's going to cause this class to have to take a test if you aren't going to write down your notes. If it doesn't look exactly like mine, you're not taking notes. So, together, over, alone for one person, plus together, over, alone. And if you think about it, the together time is less than the alone time, so we have a legitimate fraction plus a legitimate fraction that could add up to equal one whole. If we swapped it, we would have improper fraction plus improper fraction could never equal one whole. It would never work. So it's always together, which is smaller, over, alone, which is larger, so that we actually have real fractions, okay, not improper. And that's how I set up my situation. So I look through my information. If they give me the together time, I put it in the top spot of the fractions. If they give me the individual times, I put them in the bottom. One of those three pieces of information has to be missing. Sometimes they give me together and the alone time for the person one, but they say, well, how long would it take the person two to do it by themselves? Sometimes they say, I've got alone time for person one, alone time for person two, and I don't know how long it's going to take them together. The difference between what you saw in the book and what you're seeing here is that often the variable is in the numerator and not in the denominator, okay? The key thing is to have one complete job, okay? So that is a scenario. Now we could change this slightly if they one person starts, other joins later. The only difference in the fractions that we create is that if one person comes later, then they're not doing their alone time. So what we're going to do is, instead of saying alone, we're going to say actual. So it's still, how long do they work together? Or let's do it this time, not together. So this is your actual time, sorry. Versus how long it would take them alone. Now, some people would take these two actual times are going to be different, because if somebody starts, they're going to work longer than the second person. So again, this is your person 1. This is your person 2. So instead of saying together time, you're actually, how long did each person actually spend on the job? Okay, so again, you've got here 4 numbers. They're going to give you 3 numbers. You've got to figure out the missing one. Okay, because if somebody works a different amount of time than another, the 2 actual times won't be the same. They'll be different, independent. Third scenario. This deals with draining, evaporation. How do you think that's going to change how we write our equation if we've got 2 things working together, but one thing is draining or one thing is evaporating? Brian?
Will we solve like a subtraction problem?
Yeah, instead of it being addition, the only thing that changes is it becomes subtraction, because it's taking twice as long. And I can give you a real good scenario of this one. So this one would be together over alone, and this would be the bigger guy, minus together over alone, equals 1 job done. So here's a scenario, and this does work. Don't go home and do it, especially now that we're in a drought. Are you aware that you can put the tap on in your sink, and there will come a point when your sink is full? Drain's open, but you can fill up your sink. Why? Miles?
Because the rate of how much water comes into the sink is faster than the rate of the water, or the rate that the water is draining out of the sink.
Exactly. The volume of water that's coming out of the sink is not the same amount of water that is draining. It's not like what comes out drains immediately like that. And so it pools to the point where you can not only fill up your sink, but it will overflow once it gets to that point. I actually had a student went home and did this one year. Oh my gosh, she got so much trouble with her parents, but I didn't tell you to do it. But you have to, this is reality. Now, in my case at home, it happens every day because my sink is somewhat clogged, so it fills up very quickly and it drains extraordinarily slowly because it needs to get cleaned out, and we haven't been able to get a plumber over to the house yet. So anytime you hear something about draining and evaporating, now it's the same as the first scenario, except for it's a subtraction problem. Okay? So let's see if we can find a problem of each of these that you could do. Okay, so if you would look in your books and open up to page 458. I'm going to give you a couple of different problems to look at. So, page 458, let's look at just problem 1. So it says it takes painter A 3 hours to paint a certain area of a house. It takes painter B 5 hours to do the same job. How long would it take them, working together, to do the painting job? So our job is to figure out, is this scenario 1 where they start to finish work together? Is this scenario 2 where one guy starts and the other one joins him? Or is this scenario 3 where one person's working and the other one's kind of working against that person? So of the 3, which one is it? It's the first one, right? So we have them working together from start to finish. So let's identify the key information. So what does the 3 hours represent? It's A's time alone. So A alone would equal 3 hours. And what did 5 represent? B alone. And what is it that we're trying to figure out? What is it? Together. It's that key word, together. That's our unknown. So our together time is our x. So we create our fractions. Together over alone plus together over alone equals one complete job. Okay, what do I need to do to get rid of fractions? Multiply by 15. And we get 5x plus 3x equals 15. Okay, isn't this a little creepy? Do you not recognize these numbers? Didn't we just do this in that last problem? That's kind of weird. So we get 8x equals 15 divided by 8. And we get x equals 1 7/8. So we just write the answer as 1 7/8 hours. Okay. Now, here's the thing about workers. Yes, it takes worker 1 3 hours to do the job by himself. Yes, it takes worker 2 to do the job. It takes 5 hours for him to do the job alone. It literally takes him less than 2 hours. But what you get charged is either 3 to 5 hours. They'll charge you their alone time, but they'll get the job done faster. Mechanics work on this perspective. They have what they call flag hours. How much time should it take you to get this job done? And that's what they get paid. The beauty on making money is to get the job done faster so they can do more jobs. And that's how they make their money. Okay? So you don't pay for minute-by-minute work on anything. You get paid on a profit margin for the worker, knowing, hey, it's only going to take me less than 2 hours to get this job done, but I'm going to charge them 4 hours for it. And that's the way it is. But they're doing you a service, right? Okay, so let's try another problem. Let's see. That's another together time. Hold on. Let's look at number 11. Kirsten can type a 50-page paper in 8 hours. Last month, Kirsten and Courtney together typed a 50-page paper in 6 hours. How long would it take Courtney to type a 50-page paper on her own? What's missing in this particular case? Somebody's alone time. So let's do that one. So 8 hours represents what? So Kirsten alone is 8. What did the 6 represent? 6 hours. That's the together time. And what are we solving for? Courtney alone. That's our x. Now, the setup is the same. Together over alone. That represents Kirsten's portion of the job. Plus, together over alone. That represents Courtney's portion of the job. Equals one complete job. Now, you have a couple options in a problem like this. What do you notice about the first fraction? You could reduce it. Do you need to? No. What would I multiply by to get rid of the fractions? I'm going to multiply everything by 8x. So on the first one, the 8's cancel, leaving me with 6x. On the second one, the x's cancel, leaving me with 48, and over here we have 8x. So, bless you, I'm going to subtract 6x from both sides, do the symmetric property, that gives me 2x equals 48, and this is why you don't ask Courtney to help you type something. Courtney would take 24 hours to type the same page that Kirsten took 8 hours. Yeah. This is why I don't like doing projects with groups, because of the 8-24 perspective, where you always have somebody who's willing to get the work done in 8 hours, and then you've got that person on your team who takes 24 hours to do their part, okay? This is why I have a problem with projects. That's pretty bad, isn't that? Okay? All right, next one I want to do deals with number 15. It takes 10 hours to fill a pool with water and 20 hours to drain it. If the pool is empty and the drain is open, how long will it take to fill the pool and for the water police to come and fine you lots and lots of money in this drought? Because that's what's going to happen. Do you guys see another water break in LA? Water main break? Oh, jeez. I'm like, this, I've never seen it happen so much in 1 year. It's terrible. All right. So, of our 3 scenarios, which one is this? Yeah, this is the last one. We've got draining happening at the same time we're filling. So which one would be considered the bigger one? Filling. Even though it takes less time. The less time it takes, the faster the job gets done. The slower one, the draining, is going to come after the subtraction. If we did it the other way, we'd get a negative answer. So anytime you get a negative answer in these, you realize you've put things in the wrong order. So let's see. What does 10 hours represent? The pool fill. That's your 10. And the 20? That's drain. And what's our x? So, together, right? That's our missing piece, is the together. So, we take the main guy, the faster guy, and it's together over alone. So we got x over 10 to represent filling up the pool. Minus together over drain. That's the slower one. So again, you kind of think about it this way as faster, slower. Equals 1 complete job. Okay, what am I going to do to get rid of fractions? Multiply by 20. So 10 goes into 20 twice. 2 times x is 2x. 20 cancels out, leaving me an x equals 20. And we have x equals 20. So what normally takes 10 hours to fill the pool, but because the drain is open, it would take 20 hours. But here's the deal. It would be full for a second. Okay? And then we're either going to overflow or we're going to start draining. So it just kind of depends. But again, that's really wasteful. This is not politically correct to do this. So just remember that. All right, let's see if I can find one more. That will be pretty good. I think that will cover you for the worksheet you have tonight.